Okay guys, so in this video we'll understand how top P, top K and temperature parameter are used to generate next token in LLM, right? So this is the topic of today's video. And to understand this thing, we have taken an example sentence which is this. Um, this the cat is on the, so what I'm assuming is the cat is on the has already been generated by LM, and now it has to identify what will come after the, that means what will come over here in this blank space, right? This is what LM has to identify. तो इसको समझने के लिए पहले हम लोग ये समझते हैं कि LLM इंटरनली काम कैसे करता है, ठीक है? तो होता क्या है एक्चुअली, हर एक LLM के पास एक vocabulary रहती है. For example, here too I have taken a sample vocabulary which has 16 tokens, right? So जो ओरिजिनल LLM होते हैं ना, जो कि GPT हो गए, जेमिनी हो गए, उनके पास भी एक ऐसी vocabulary रहती है. बट वो vocabulary जो होती है वो बहुत यूज होती है. उसमें 60,000 से लेके 1 लाख तक tokens हो सकते हैं, ठीक है? But to keep this particular example very simple, what I have done, I have just taken 16 tokens in my vocabulary. Now what will happen? One of these tokens will become the next token in the sentence that I have taken, right? One of that token will be coming over here, right? Okay, so now how that one token will be decided? So to decide that, what LM does is it generates the probability against each of these tokens, right? And how is that probability is calculated? So for that, LM uses the concept of conditional probability, right? So what it says is this. It says these are the sequence of tokens that I have already generated. Now given this sequence, what is the probability of I to become the next token? You see, we have I over here, right? So it says I have already generated these words. Now given these words, what is the probability of I to be the next token? Similarly, what is the probability of like to be the next token? What is the probability of eat to be the next token? And likewise, it calculates the probability of each of these tokens in the vocabulary. अब ये प्रोबेबिलिटी कैसे कैलकुलेट होती है, कंडीशनल प्रोबेबिलिटी कैसे काम करती है, दैट इटसेल्फ इज अ वेरी डिटेल्ड टॉपिक टू टॉक अबाउट, which I'll not be doing in this video. For now, just assume that some process it has done, and after that it has generated the probability, right? And that probability looks something like this. So you see, Matt has the probability which is 0.5, Pi has 0.3, dog has 0.198, and likewise each token has at least some probability associated, right? Now if you have temperature equal to 0, right? So in that case, the token which has the highest probability will become your next token. That means here in this case, Matt, which because Matt has the highest probability, it will become your next token. And the final sentence would be something like this: the cat is on the mat. Okay, but if you do not have temperature equal to 0 and top k equal to 3, then in that case what will happen? So in that case, the tokens, that means the top 3 tokens with the highest probability will be selected, and any of them can be your next token. Okay, so suppose I have selected these 3 tokens, right? Now any of these tokens can be our next token. But to decide that next token, कुछ और प्रोसेस भी होता है, और वो प्रोसेस क्या होता है वो समझते हैं हम लोग. तो अगर आप इन प्रोबेबिलिटीज को देखोगे, तो ये प्रोबेबिलिटीज जो है वो नॉर्मलाइज नहीं है. फिर दैट मीन्स अगर आप इन प्रोबेबिलिटीज का सम करोगे, दैट विल नॉट बी इक्वल टू 1. ओके, सो हम लोग उसके लिए करते क्या है, हम लोग इन टोकन्स को फिर से एक सॉफ्ट मैथ के अंदर डालते हैं. उसके बाद सॉफ्ट मैथ क्या करता है, हम लोगों को एक नई प्रोबेबिलिटी देता है, which if you'll add will be equal, I mean if which if you'll add, the sum of those probability will be equal to 1, right? So now after that, what this is saying, what this result is saying, so this result is saying that Matt has the 50% of the chances to become your next token, 5 has 30% of the chances to become your next token, and dog has 20% of the chances to become your next token. And if you want to understand in like a different way or simpler way, just think that we have a list in which Matt is appearing 5 times, pipe is appearing 3 times, and dog is appearing 2 times. And we have to select a token from this list randomly. Okay, now because we have Matt appearing 5 times, it has the highest probability to get selected. It has 50% of the chances to get selected, right? Pipe is appearing 3 times. It has lesser probability than mat to get selected, right? And dog, because it is appearing the least number of times, it has the lowest probability to get selected, right? But each of these tokens have at least some probability to get selected, right? So this is how top k parameter works. Now let's understand how top p parameter works, right? So to understand top p parameter, what I've done, I have taken top p equal to 0.85. Okay. Now the probabilities that you are seeing here is exactly the same probability that we had got after applying conditional probability. Now that means um, that means we had applied this conditional probability, right? And after that we had these probabilities, right? So what I've done, I have exactly copied this thing from here and pasted it over there, right? So this is nothing but exactly the same probability that we had got after applying conditional probability, right? So what happens in case of top P, that we keep on selecting the tokens as long as the sum of the probabilities of the selected tokens is not crossing this threshold, right? Now what do I mean by that? So we'll select mat and we'll see that is the probability of mat greater than 0.85? No, it's not, right? So we'll select the mat. Then we'll select pipe and then we'll see is the sum of these two probabilities greater than top p? No, it's not, because it's 0.8 and here we have 0.85. So we'll select pipe as well, right? Now we'll select dog. So we'll see that is the sum of these three probabilities greater than 0.85? What we'll find is yes, it is greater than 0.85. So what we'll do, we'll not select dog and we'll not select any other token which is coming afterward, right? So what we'll do, we'll select only these two tokens, right? So that is what we have done. We have selected these two tokens. Now again, since these probabilities are not normalized, we'll put these tokens inside softmax and after that we'll get the normalized probabilities, right? Now what these probabilities are saying is that mat has 60% of the chances to become your next token and pipe has 40% of the chances to become your next token. And same process we'll do that we did with top k. Again, we'll create a separate list in which we'll put mat 6 times and we'll put pi 4 times and then we select one token randomly and that token will become your next token. So this is how top p parameter works. I hope that you would have understood how temperature, top k and top p parameter works. If you have any question, you can ask me that in the comment section, right?